Hi Chemistry, we're doing lab experiment 14.2 today. Print out a lab sheet or grab a blank sheet of paper and let's get to work. You're going to write your name at the top, you're going to write lab number 14.2, and you're going to write the effect of a catalyst on the decomposition of hydrogen peroxide. Hydrogen peroxide, when it's just left out in the open, it will naturally decompose. Hydrogen peroxide is H2O2, 2 hydrogens, 2 oxygens, and it will naturally decompose into H2O, water, and O2, which is a gas. If you leave hydrogen peroxide sit out long enough, you're going to see some little tiny bubbles forming every now and again, kind of whenever it wants to, and it's really slow. We are going to do something to speed up that rate of reaction. The last lab we did, 14.1, we talked about 3 ways to change the rate of reaction, to speed it up. We changed the surface area. Remember we powdered that Alka-Seltzer, or Tums, that Tums tablet, the antacid? We powdered it, and it made the reaction happen faster because there was more surface area where the reaction could take place. Another thing we did is we heated up some of the elements used in our chemical rate of, our chemical conversion. And the heat, the increased heat, increased the rate of reaction. Those molecules are able to smash into each other faster, and they have to smash into each other in order for that chemical change to happen. The third way we did it was, what we did is we diluted our chemicals, but had we increased our chemical dilution, we would have increased our chemical rate of reaction. Today we're going to do something different. We're going to increase the chemical reaction rate by doing something else. We're going to add something to it. We're going to add a catalyst. A catalyst is something that can be added to an equation to speed it up, or a catalyst can be added to a chemical reaction and it will speed up that rate of reaction. So hydrogen peroxide decomposing all on its own, kind of boring. Let's do something cool. Let's take some hydrogen peroxide, let's put in some yeast, and let's see what happens. Read your book, read especially the paragraph prior to your experiment. Take a break now, get your lab sheet, get it set up, whatever. Come back and watch me do the experiment. You can do this at home. Hydrogen peroxide and yeast, you probably have that at home. Okay, you can do it with me, you can just watch, whatever you choose to do. Come back to me in a minute. All right, hydrogen peroxide. I doubled my measurements because I have a larger jar. This is a 1/4 cup of hydrogen peroxide. And if you see, not much is happening here. I don't see any bubbles, nothing foamy, cannot see the decomposition of my hydrogen peroxide into water and oxygen. So what we're going to do is speed things up a bit. You ready? This is the fun part. This is yeast. You probably have yeast at home. Again, I'm doubling my measurement because I have a larger jar. All right, now the reaction takes place wherever the hydrogen peroxide is touching the yeast. So I'm going to hold this up nice and close. Hopefully you can tell there is some foaminess happening. Okay, a little bit of foaminess. Now I'm going to gently swirl, trying to mix in. Yeast is grainy, they're little individual grains, and I'm trying to mix it into the liquid inside in hopes to increase my surface area, thereby increasing, more bubbles. Oh, hush.
It is interesting.
Of course it's interesting.
Somewhat.
Chemistry is cool. All sciences are
So
cool.
wait, how does this thing make bread?
In theory, that's really rising kind of quick.
Wow. Yeah, this is like better than baking soda and vinegar, almost.
Well, okay. All right. All right, so we have quite a reaction here. You see all these little bubbles, okay? The reaction is happening right here where my bubbles are forming. These are just bubbles that they're already full of the oxygen and they're breaking up ahead, or up on top. Okay, so what did we see? We saw hydrogen peroxide decomposing at its natural rate, and it was super slow. We added a catalyst, a heterogeneous catalyst, which means we added a solid into a liquid. Hetero means different. Had we added a liquid catalyst, we would have called it a homogeneous catalyst because we're adding a liquid to a liquid, same things. So anyhow, okay, so it's a heterogeneous catalyst. We've added that. It decreased the activation energy needed for our experiment. Our chemical reaction took place super fast. As you can see, these bubbles, we're still getting some bubbles. Not so many as we were at first, but that means to me that our reaction is almost complete. So, as Zeke said, can you use it in baking? You know, in theory, hydrogen peroxide completely breaks down to water and O2, liquid water and gaseous O2. And yeast, of course, is something, it doesn't get used up. No change happens to it. It still is in its same state as it was before. So yeah, I guess you could, but this is a chemistry experiment, and I'm going to go with no. Don't eat your chemistry experiments. That's not cool. Don't do it. All right, here's what I want you to see. This is on the next page. This is figure 14.4. This is our reaction without a catalyst. It takes this much energy. We have to gather this much energy. Okay, we finally have enough, and let's do our reaction. There's a lot of energy used here. A lot of potential energy is used by our reaction. However, if we add a catalyst, our max potential energy is like significantly lower. So here it looks like about 100 units of energy, and here it's about 150 units of energy. We've reduced energy required by 1/3 simply by adding a catalyst, okay? That's one thing I need you to know. Understand that. The catalyst reduces the amount of energy, of potential energy required. Something else to know, down here, just your book is going to be different. That's okay. Look for these. Catalysts speed up the reaction by lowering activation energy. And here we go. Here's another one. Heterogeneous and homogeneous catalysts, okay? Hetero means different. Homo means same. If you have a liquid catalyst that you're adding into a liquid reaction, that would be homogeneous catalyst. We actually added a solid, the yeast is a solid, into a liquid, so we're going to call that a heterogeneous catalyst. And like I said, read all these bold sentences in your book. They're going to help you out with the questions at the end of your chapter. Something that we use every day that is a catalyst is the catalytic converter on a vehicle. When cars are running, when engines are running, they produce carbon monoxide. This is something dangerous. It's actually a poison. You probably have carbon monoxide detectors in your own home. What is less poisonous is carbon dioxide. So what we do is, back in the 70s, someone said, hey, I have this great idea. Let's use a catalyst, a heterogeneous catalyst, to help convert that carbon monoxide to something less deadly. So they have catalytic converters in vehicles now. The gas that your motor produces, the exhaust that your motor produces, goes through that catalytic converter. Inside the catalytic converter are mesh screens that are made of platinum or copper. And the platinum or copper helps facilitate, acts as a catalyst for the chemical reaction to change that carbon monoxide into something different and less deadly for our world and for us. That's something that we use every single day. What I want you to do now, you've seen the lab, you've made your hypothesis, what do you think is going to happen? You've seen the lab. I want you to write down if we used a heterogeneous catalyst or a homogeneous catalyst, and I want you to write down a conclusion. What happened? Did it work? Did it not work? Was the catalyst used up? Was it still there? Are there ways that we use a catalyst in everyday life? We've talked about it. It's all there. Watch the movie again if you need to. Read your book if you need to. If you guys have questions, go ahead and email me. If I don't know the answer, I'm not going to just make something up. I'll tell you, but I'll tell you what. Read those bold sentences in your book, and I think you'll find your answers. Okay? Thanks. Have a great day.